Hi, I'm Shannon Henry, an applications engineer here at EMA Design Automation. Today we will be discussing vias and why it's important to define via requirements at the beginning of your design. But first, what exactly is a via? Vias are plated holes connecting inner layers or one side of the board to the other. There are three types: through hole, blind, and buried. Vias can be different types and sizes, but should be small enough to not take up valuable room on the PCB and large enough to withstand the manufacturing process. So how do you determine which type is right for your design? Vias can be used to complete traces, EMI shielding, or thermal management. Through-hole vias are the most common and connect the top side of the board to the bottom. Blind vias connect an outer layer to an inner layer. This will create an additional cost in the manufacturing process due to controlled depth drilling and additional plating requirements. Buried vias connect two inner layers. This will add even higher costs in the manufacturing process. Buried vias are created during lamination. The inner layers are printed, plated, and etched, then laminated together. They are then sandwiched between the outer layers and all laminated together. Buried vias are great for densely routed designs, as the top and bottom layers can still be used for routing purposes. Vias can be drilled or laser formed. Drilled vias are kept small for space concerns. However, the size of the via depends on the thickness of the PCB. Due to the manufacturing process for drilled vias, the hole size must conform to a specific aspect ratio. The aspect ratio is the depth to width ratio and can be calculated with the PCB thickness and hole size. The best aspect ratio for manufacturing is 8:1. Aspect ratios are very important in laser formed vias. It should be noted that a via with a 2:1 aspect ratio is considered manufacturable. Now that the size of the via has been determined, you must also calculate the required pad size. The relationship between the hole and the pad will create the annular ring. This is a supporting copper ring to ensure the electrical connection will be made, even if the hole is drilled at worst case tolerance. To calculate the required pad size, first calculate the maximum hole size by summing the hole size, tolerance, additional plating size, positional tolerance to get the maximum hole size. The additional plating and positional tolerance required are usually 0.002 inches. Then add the annular ring tolerance to get the minimum pad size. Please note that it is always a good idea to increase the size of the pad if your design allows for ease of manufacturability. Also, to save time and reduce errors, create a library of completed pad stacks for these different types of vias. If you have any additional topics you would like to see, go ahead and add them in the comments below. In the meantime, be on the lookout for more Whiteboard Wednesday sessions from the PCB design experts here at EMA Design Automation.